In this section, we'd like to look at ionisation energies. Let's start with the definition. So, ionisation energy is the energy needed to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. Another way that you'll see this phrased is that it's the energy required to remove 1 electron from each atom in 1 mole of gaseous atoms. Quite often we'll be asked to represent this as an equation. Let's do it with sodium. So if we take a sodium atom, a simple diagram for that. So we've got 2 in the first shell, 8 in the second, and 1 electron in the third outside shell. So what's happening with the first ionisation energy is that we're going to be removing this outside electron. So basically we're going to get rid of that outside shell, and that electron is now just going to be somewhere else. In terms of the equation, they'll want to see that we've put the state symbols in. So sodium atoms are in the gaseous form, and over here we have our electron now no longer attached to the sodium. The sodium has lost its electron, so it now needs to be positively charged, so we can see it's balanced in terms of charge, and those sodium ions are gaseous as well. So back to the notes page, the first ionisation energy of sodium positive charge, and there's the electron. Let's think about the factors which might influence first ionisation energies. To do this, what I'd like to do is draw a bit of an atom there, just a simple atom, and look at the shells and the nucleus that we've got. So basically, ionisation energy is a reflection of how well the nucleus is able to attract the outside electron that we're trying to remove. And if we draw this image of the atom, kind of all of our answers are there already. So number 1, well, it's the nucleus which contains the protons, and it's the protons which are attracting the electrons. So factor number 1 will be the number of protons. So the more protons that we've got, the greater the attraction. Number 2 is going to be the number of shells I've drawn. So the more shells we introduce, the more difficult it will be to remove the electron. This is often referred to as simply the atomic radius. So the greater the atomic radius, the easier it is to remove an electron. And very much linked to the number of shells is the shielding. So with more shells comes more shielding, and this is where the inner shells of electrons shield the outer electrons, making it easier to remove the electron and therefore a lower ionisation energy.